Hi everyone, Mr. Waiter here, and as always we're going to start off with the answers to the last assignment, and then following that we're going to be going over how to name molecular compounds. So to start, we had sodium bromide, iron 3 phosphide, cobalt 2 fluoride, rubidium nitride, and lead 4 oxide. And for those ones we had to find the formula. These were the ones that were new material, and I think were the harder ones. In order to do this, you need to know the charges. And in order to find the charges, don't forget that you have this handy dandy table, the table of ions. So whenever you're doing one of those, if it's an ionic compound, use this table. Okay, I've got it right here. Just going to set it down here. So sodium bromide. Sodium is +1 and bromide is -1. Since they cancel each other out naturally, +1 and -1, I only need one of each. So my formula for that then is going to be NaBr. Next up we've got iron 3 phosphide. And I think I'm going to switch over the marker. So if it's iron 3, that makes it +3. And phosphide, which is right here, element 15, is -3. That one was also a simple one where you only needed one of each. So that means iron, which is Fe, and P for phosphide. I'm going to switch back to green. Now we have cobalt 2 fluoride. This one requires a double of one of them because cobalt is +2 and fluoride is -1. So that means that we need twice as many fluorides to cancel out the cobalt. You would need another fluoride because if you have +2 and -1, you still have +1. So you would need another fluoride to cancel out that remaining +1. So this is going to be CO for the cobalt, and then for fluoride, that's F. And we need 2 of the fluorides, so it's F2. Next up is rubidium nitride. So rubidium is probably one you don't know off the top of your head, but rubidium is element 37. It's right here. It is a +1. So +1. And then you have nitride. Nitride is -3. So you're going to need 3 times as many rubidium as you would need nitride. So that means you're going to have Rb for rubidium, and then for the nitride you have N. We need 3 times as many rubidium, so Rb3 and 1 N for nitrogen. Back to green. Last one, lead 4 oxide. The 4 is telling us it has a +4 charge, so I'm going to put +4, and oxide -2. Well, there's a +4 and a -2 charge here. You're going to need twice as many oxide as you would need lead to balance that. So I'm just going to put Pb for lead. Pb is lead, element 82, right there. And I need 2 oxides to balance that, so O2. Okay, so that's the formula ones. Those are done. Next up we have going from formula to name. Now for these, I should keep this over here actually. The only time that you don't just put metal blank-eyed is if it can make more than one charge. So when you do these ones, you have to take a look at the table here to check that. So first up, potassium oxide. Potassium only has one type of charge. So you would just write potassium and oxide. I don't need to put potassium 1 because potassium only makes one kind of charge. All right, next up you have barium, which has one type of charge, and P is phosphorus, which is phosphide. So that would be barium phosphide. Next up we have Pb, which is lead, and lead, as we know from previous examples, has more than one kind of charge. It makes +2 and +4 commonly, and it can make others too. So, which one are we going to use? Well, we need to know the charge of the sulfur in order to solve this one. So, sulfur is a -2. If there are 2 of each, that means that they have to have the same charge if they're balanced, and there's the same amount of both. So that means that the lead has to be +2. So that means this would be called lead 2, with the Roman numeral for 2, sulfide. Next up we have strontium, which is Sr. Strontium is a +2, it's element 38, and it only makes one type of charge, so we don't need to worry about the charge it has. And then fluoride, so that would make it strontium fluoride. And then last on our list here, we have FeCl2. Iron can make more than one kind of charge, so we're going to have to list it. If this is chloride, which is -1, and there's 2 of it, that means our total negative charge is -1 times 2, so -2. We have to cancel that with a positive, and iron makes a +2, which is perfect. So this is going to be iron 2 chloride. All right, so that's all the names for the homework assignment. Now for the new stuff. And trust me, the new stuff is actually easier than the old stuff. So, first, why do we need to know this? So, this picture says, well, first of all, it looks like it's a danger sign, right? A warning sign. Dihydrogen monoxide containment unit. Warning, can cause serious injury or death if inhaled. May cause micturition and acute tissue hydration. That probably sounds scary if you don't know what dihydrogen monoxide is, and if you don't know what micturition is, and you don't know what acute tissue hydration is. What this is literally telling you is, warning, water containment unit. Can cause serious injury or death if inhaled. That's drowning. May cause micturition. That's peeing. And acute tissue hydration. That's getting hydrated. So those are all actually important things. There's a meme on Know Your Meme about this, because there's a hoax that went around because people did not know what this was. And they made a list of things and sent out. This happened in 1994, but it happened again afterwards multiple times in different places and times. This went around online a couple years ago, actually, too. It makes the rounds every, 2 to 4 years. So anyways, they had this list of all of these things that water actually does, but if you don't know what that stuff means, it's going to sound pretty terrifying. It's fatal if inhaled. Yeah, you can drown. May cause severe burns. Yeah, if it's too hot, it burns you. Scalding. Contributes to the greenhouse effect. Right, because water vapor carries heat. Accelerates corrosion. Yes, water rusts things. Can cause electrical failure. Yes, because if you put water onto a computer, it'll fry itself. So you notice these things are all true. It's used as a coolant and a solvent. It puts out fires. It distributes pesticides. And when you wash something, it remains because you wash it with water, which is this. So the point is, not knowing how chemicals are named has not only led to all sorts of fun jokes because of people getting memed on, but it's a real problem if you don't know the basic ideas in science. And if you don't believe that now with COVID, I don't know if you ever will. So anyways, this is simple. To name covalent compounds, which are called molecular compounds, all you need to do is know these prefixes. 1 through 10. Mono, 1. Di, 2. Tri, 3. Tetra, 4. Which, by the way, the game Tetris is named after that because all the blocks in Tetris have 4 pieces. If you don't believe me, check it out. Penta is 5. Hexa is 6. Hepta is 7. Octa is 8. Nona is 9. And Deca is 10. And in order to make this, you're always going to have 2 nonmetals. That means these are going to be the ones that have minus charges on your table of ions, but we're not worrying about their charges because charge isn't why these bond the way they do. This may look really complicated, but all this is saying is you're going to take the first nonmetal and the second nonmetal, and then you're going to use the prefixes before it. The second one ends in "ide." So, for example, this one is N2O5. there are 2 nitrogens, so you have dinitrogen, right? So you have di for 2. And then you have pentoxide, because pent is for penta, which goes with the 5. That's really it. CO2, carbon dioxide. The reason it doesn't have mono, by the way, is because mono is the only one you skip, and that's only if it's the first element. That might not come up a lot, but it explains why carbon dioxide is that instead of monocarbon dioxide. I'll know what you mean if you say monocarbon, but you don't have to. Okay, so in picture form, same idea. The element on the left side is usually going to be the one that is the farthest to the left or bottom. So if you have one that's farther down to the left, like nitrogen compared to oxygen, because nitrogen and oxygen are right next to each other, the one that's farther to the left or farther down is the first one in the formula. The one that's farther to the top right, that's oxygen in this case, goes as the last one. You're going to take the name of the element, in this case nitrogen for N2. There's 2 of it, so you put the di-nitrogen, and then you have 3 oxygens, so tri for the 3, and then oxide for the oxygen. Dinitrogen trioxide. Okay, so here's a list of examples. You've got carbon monoxide, diphosphorus pentoxide, boron trichloride, carbon tetrachloride, and notice the number parts are bolded in blue, or highlighted in blue. Carbon tetrachloride, 1 carbon, so you don't need the mono, because it's the first one. Tetrachloride for the 4. Phosphorus pentachloride, 5 for the penta. Sulfur hexabromide, and iodine heptafluoride for the 7 for the fluorides there. So, really quick, pause the video and try and answer these ones on your own first. So, pause the video now, look at those examples, and use this chart on the right side over here, and see if you can figure out the answers. Okay, now for the answers. SO2 is sulfur dioxide. There are 2 sulfurs, sorry, there's 2 oxygens, so it's dioxide, and there's 1 sulfur. And since sulfur is farther to the left than farther down than oxygen, it goes first. So sulfur dioxide. Also, you'll notice the formula is usually written in order that they're in too. Next up is silicon tetraiodide, and that is because there are 4 iodine and there is 1 silicon. Next up is sulfur hexafluoride. If you've ever heard what it sounds like to have helium, your voice goes up really high pitched. Sulfur hexafluoride does the opposite, where it makes your voice really low. But hexa for 6, fluoride, because there are 6 fluorides. And then it's just sulfur because there's 1 sulfur. And then the last one on the list here is carbon disulfide, because there are 2 sulfurs and 1 carbon. All right, for today's assignment, it's a fairly simple one. All I'm going to ask you to do is to fill in the blanks in this chart here. You're going to take dihydrogen monoxide and give me its formula. Silicon dioxide, give me its formula. Trinitrogen pentoxide, give me its formula. Then you have N2O6, give me its name. Si2I6, give me its name. B3Cl5, give me its name. And then the last one is you take dinitrogen tetraiodide and give me its formula.